All right, so we're going to do a quick example of a direct proof today. And what you need to understand is what's shown here. In proof, we can express any odd number as 2n plus 1, where n is an element of the integers. Anytime we put an integer in here, if we multiply it by 2, then add 1, we get an odd number. An even number can be expressed in proof as the expression 2n, where n is an element of the integers. When you introduce variables into a proof, you must define what type of number they are, which is what this statement is right here. N is an element of the integers, and here we go with our proof. Use a proof to show that the sum of two odd numbers is always even. All right, so let's define two odd numbers. Let P equals 2k plus 1, where k is an element of the integers, and let Q equals 2r plus 1. Notice I'm using different variables here because these aren't necessarily the same numbers, where r is an element of the integers also. So we want to show that the sum of these is always going to be even. So P plus Q. Using the notation from the previous slide, we should be thinking, okay, we're trying to show that this sum can be written as 2 times an integer. So let's see what we can do. So this is going to be 2k plus 1 plus 2r plus 1. And if we combine like terms, we get 2k plus 2r plus 2, and all that, there's factorable there. We can factor 2 out. K plus r plus 1. Therefore, since k plus r plus 1 is an element of the integers, P plus Q is even. And we have sufficiently proven that the sum of two odd numbers up here is an even number down here. Done. We're taking clear deductive steps as we work through this proof. You cannot leave anything to the, well, you know what I mean. That's not good enough with proof, ladies and gentlemen. You have to be very clear and very explicit with everything that you write down.